The purpose of this webinar is to provide for the new user of Maple enough information to make the first interactions with the software comfortable, effective, and efficient. So we need to look at the interface, how to enter mathematics, and how to interact with the entered math. When Maple is first launched, it most likely looks something like what you see here on the screen. There is a short video here, it runs about 3 minutes. It has a few bits of useful information. There is a longer video here, about 37 minutes. It's got a number of interesting pieces of information. It's worth going through. It will mention the Maple portal. We'll talk about that. That's a useful place to find information. There is this presentation. How do I choose between using a worksheet or a document? Okay, here it discusses worksheet, here it discusses document. I'll give you a quick overview of that choice. I will primarily concentrate on the document, but this way you'd get some idea of what your two approaches to Maple might be. Here you see what's called the context panel. It's a dynamic reaction to the math that you're doing, and different options will show up depending on what math is being worked on. And here is the or a stack of palettes. They look like this when they're opened. They have math templates that you can insert and make use of. Now, a quick look at the worksheet will show these red prompts. Every time I hit the enter key, I get another red prompt. At a red prompt, I can type in a Maple command. For example, the differentiation command, and the syntax that belongs to that command being illustrated here, and the entry here is linear. It's actually text. It's the characters that you get on a typewriter keyboard. And all you can do here is hit the enter key, and Maple does the computation and centers the response in the middle of the screen. Now, if you switch to math and type the same command, it looks like this. And when you enter x squared, it typesets. Right arrow key to come out of that. Hit the enter key, you get the same 2x. If you go back to math mode and go to this calculus palette, you will see a differentiation template. You can fill that in, hit the enter key, hit the tab key to move, put in x squared. Again, hit the enter key, you get a centered 2x. So working in a worksheet requires that you know syntax and commands. You can use templates if you work in math mode. Now, you can interact with this computed math through the context panel. So, for example, next to a 2x, I can select integrate with respect to x. And I get x squared, and notice that Maple has written in the command that lurks behind that operation. So if you're into commands, there is a way to use Maple to learn the commands, or you would have to go to the help pages and extract the usage of the commands. Now, I'm going to work in a document where there'll be a minimal or non-existent need to know commands. And for a first rummaging through Maple, it's probably easier, if you don't know any of the commands, to use syntax-free approaches that I'll show you in the document, rather than to struggle to figure out every time you want to do something, what is the appropriate command for that. So here we are in a document. Then you can always get a document or a worksheet by going to File, New, and then you have your choice, worksheet or document. Now I've got my Maple set up that when I want a new whatever, it turns up as a document, but you can adjust that if you want to always stay in worksheets. Okay, so my recommendation is that one of the first things you do when you're in this document is go to the View menu and select Markers. Now keep your eye on this left edge of the workspace. So we choose Markers, and you notice that there is a column that opens, a gray column that opens. Each time I hit the Enter key, I get one of these little rectangles. They delineate document blocks that shows you where you can put stuff. I find it very useful to be able to see where I can actually enter math. There's a second thing that I would recommend that you take care of. Go back to the View menu and select Palettes. You have these options. You can show specific palettes, or you can show all the palettes, or you can show just the default palettes. I've made my choices and I've arranged them in a certain order. You can change the order by a drag and drop process. I like to have my expression palette at the top, calculus palette, and then you see favorites. Typically the favorites palette is empty. I've got mine populated. The way you populate it is to find somewhere a symbol that you want to make use of frequently. Right click on it. I have a 2-button mouse because I'm in Windows. But you get this option, Add to Favorites, and you have the same thing in the other operating systems. And that's how you populate a favorites palette with those items that you use frequently. Okay, so we're some 8 minutes into this webinar, and it's time to actually start doing some math. So here I am in the document, and I want to enter some math. I showed that you could use the command if you know it. So that would be the differentiation command. You have the choice of hitting the Enter key, or go over here to the context panel, and you see this option, Evaluate and Display in Line. Evaluate this command and display the result in line, and there are keyboard equivalents. I always use Control equal. Believe Alt Enter is an alternative, but my fingers are trained to do Control equal. And what happens is you get 2x on the right side of an equal sign, so you get a mathematical statement. Now, in a document using math input, which Maple calls 2D math because it has height and width, you can make use of these palettes. Template for differentiation, as we saw for the worksheet, x tab, put in x squared, and if you do Control equal, you get inline evaluation rather than a centered evaluation. Notice that when you get a centered evaluation, you pick up an equation label. If you do it inline, you don't pick up the equation label. There's one other way to do differentiation in Maple. Well, actually, there are two different ways here. Let's do this. Let's put in x squared and make use of the context panel where you see a differentiate option. You differentiate with respect to x, so you can use the context panel to do some of your manipulations. Put it back to x squared, go back to differentiate with respect to x, and you get the same thing, but now it's in line. And finally, for differentiation, a prime is understood by Maple to be differentiation with respect to x. Now that could be an apostrophe. It will work. Well, here you get derivative of x with respect to x. You're going to get 1. I'm not enamored of how that apostrophe looks. So I make use of something in my favorites palette here, a prime operator in my favorites palette. I think that typeset's nicer. You still get differentiation with respect to x. And that prime comes from this punctuation palette where you can see prime, double prime, triple prime, even a quadruple prime, which I don't use that quadruple prime. So we've seen how to put some math into a document, how to interact with it with palettes and with the context panel. Let's move on to some other mathematical operations. One of the first things you might want to check out at this point is graphing. So let's clear this stuff. I'm going to do a Control A to select everything. I'll hit the delete key, put in some document blocks. Let's draw a graph. How about graph of sine x? Now, there is in this expression palette templates for a few of the elementary functions. There's a sine, cosine. There's a palette that I don't use. So that was view, palettes, show palettes. There's one with essentially the rest of the elementary functions, and then you could get the entry of that particular function from that palette. But I know what the names are in Maple, and I don't use that palette. Okay, here's sine x. Now, whether you work without hitting an enter key or with hitting the enter key, it makes no difference. You get the same options here in the context panel. You notice you have this 2D plot right at the top, or if you go down here to plots, you would have the option 2D plot. It would be the same thing either place. So you get a graph, default minus 2 pi to 2 pi, graph of sine x. You can interact with that graph, having put this in. So you right click on the graph and you see there's a pop-up menu that lets you do stuff on the graph. There's also a toolbar across the top that lets you do things to the graph. Here I've just put in a grid. You can do a one-to-one scaling. If you right click and select probe info, which there's also an equivalent up in the toolbar, if you choose one of these items, how about nearest point on the line, your probe becomes a tracer that traces along the graph and gives you coordinates of points on the graph. if you find a point you like. Probe info, you can copy that data point and paste it back in here. I'm using the mouse to do the paste. There are, I believe, zoom options in the toolbar. Lets you select the section and zoom in on it, so you can interact with your graph. If you want to add something to that graph, suppose you want to see what the cosine looks like, you can either copy paste or drag and drop a formula onto an existing graph, and the graph will show the new function as well as the old one. Now I'll make a mention here of what I did to drag and drop. You do a selection, hold down the control key, and move the item, equivalent to copy paste. It's not a Maple thing, it's a Windows thing, and I believe you can do the same thing in other operating systems. So we've graphed some curves. You might ask, what about graphing a surface? So let's put in something whose graph will be a surface. And again, I'll hit the enter key, just have it centered. Plots. Now you notice you have this immediate plot 3D with the variables in the order XY. You also have that same option up here. You can click right up there. You get a graph of the surface determined by or defined by x squared plus y squared. And you can move that surface so you can look at it with different orientations. It has a right-click menu to go with it. So you can do things like change the lighting. So there's a default lighting, which means there's an external light shining on this surface. So you could change it to, I don't want a light shining on the surface. You can add, under style, things like contours. And you can have this be a graph that you see with contours, or it can be changed to take away the hash marks and you have contours on that surface. If you turn it down so that you're looking from above, it's a contour plot. Now you might ask, does this graph of a surface have that same drag and drop property? And it does. Suppose you have a plane like z equals x plus y minus 4, let's say. What happens if we drag and drop that? Oh, minus 4 is too much. So let's do a control Z, or let's just do a cut, remove that plane. Perhaps we should have had a plus 3 or something like that. Oh, it is the y plus 3. Let's drag and drop that onto the graph. And so we have the plane cutting through the graph of the surface. Okay, so it has the drag and drop property. And you saw how you can edit and make changes to what you've done. One of the advantages of working on a computer. You might now ask, what about implicit plotting? So we've already got x squared plus y squared on the screen. It has an equation label. If I set that equal to 1, I would have the graph of or the equation for a circle. Now I'm going to make use of that equation label because it will stand for the item labeled. And the way you make use of that is to do Control L. L for label, you get the Insert Label panel. You type the number 2, which which was the equation label. If you set that equal to 1 and hit the enter key, you get x squared plus y squared equals 1. So this label actually stands for that which is labeled. If you right click and change label to label reference, then the label reference becomes the item labeled so that you can see what it is that you've done. Okay, so here is the implicit definition of a circle. If you click on that, you go to plots, you have choices. Simplest choice is 2D implicit plot with the variables in the order x, y, and there you have your circle. There might be one other thing that you would check out with graphing, and that's building a simple animation. So let's put in a x squared. Now, you didn't hear me say it. You might have detected it on the screen, but between the a and the x, I put a space. A space x. Now, if I don't put that space and write ax, it's the variable ax. If you don't put a space, then you have to put an explicit multiply. So that's an asterisk, or in my keyboard it's Shift 8. And what happens is you get this center dot, or nearly center dot. None of my math books do that. It does not look like mathematics. It looks like computer stuff. So my preference is to put a space for implied multiplication. So ax squared. I want to animate what happens to this parabola as a varies. So you can select the plot builder here, or go down to plots and pick the plot builder here. You get to the same place. And notice right at the top it says, oh, maybe you want to might do an animation of a 2D graph in which the animation parameter is to be a. And then you can give a range, and you can give x a range. Build the animation. Okay, you now have an animation. The slider will control the value of a. You see it's written right up here. And you can see what happens to the graph as you move the slider. So we've put in some math, drawn some graphs. Next thing that you might want to look at is how do you make replacements and substitutions into expressions. So let's clean this up. So I'm going to do a Control A. Hit the delete key, clean that stuff off, put in some document blocks, and I'm going to create an expression, a simple polynomial here, 2x squared. And between the 2 and the x, you don't need to put the space because Maple figures that's the only thing it can possibly mean if you put a 2 then an x is 2 times x. How about plus 5x minus 7? Okay, hit the enter key. We have an expression. And you look at that and you say, I need to put x equals minus 3 in there. You can do that from the context panel. Evaluate at a point. X equals negative 3. Okay, and you get an answer. All right, so that's one way to do it. But then you ask yourself, what happens if the thing you want to replace x by is kind of messy? Something that would not be convenient to type into that little dialog box that came up. So we need something messy. So let's have pi in its floating point form. So how do we start out with a pi? Now I showed you here that I had a pi in my favorites palette. It comes from common symbols. You right click, you do add to favorites. There's a whole Greek palette. You can find a pi in there. If you can find it, there it is, pi. That would work equally well. But I'm going to tell you how to get it from the keyboard, which I find much more convenient. You have to press 3 keys simultaneously, down, up. The next key that you hit will come out in Greek. Now the three keys that you hit are Control Shift G. Okay, so Control G for Greek. Control Shift G, down, up. Then I'm going to hit the letter P for pi. So Control Shift G, hit the letter P. I've got a pi. Let me hit the Enter key. So there's a Greek letter, pi. It stands for the ratio between circumference and diameter. All right. Notice that you have an approximate in the context panel. Let's approximate to 10 digits. That's the messy thing I want to put in for X. Here's a way to do it. In my favorites palette, I have this evaluation template. You see, it stands for the eval command. And you would find that here up in expression. There it is. It's right there. Expression palette. Okay? So put in this template. What is it you want to evaluate? Well, it's that polynomial, and it has equation label 1. So Control L1, that will stand for the polynomial. Tab down here, letter X. Tab over here. What do you want X to be replaced by? Well, 3.14, 159, etc. It has an equation label, Control L4. And if I do a Control equal, I get an evaluation in line. You got a value 28 point whatever. And remember, you can change these equation labels to label reference so you can see what it is that the label stands for. There is another way to accomplish this same kind of thing, and that works if the target has a name. So let's bring back this target, Control L1, and let's go here to the context panel where it says assign to a name. I'll give it a name Q because it's an easy letter to find on the keyboard. So now the name Q is that polynomial. And in conjunction with that, we would want an equation X equals this replacement value. So let's set that equation up by typing X equals Control L4. Okay, so we have on the screen an equation X equals and a target whose name is Q. Now, there is this substitute into option that allows us to make the substitution X equals whatever into Q. And you get your 28.447. Okay, so you have this template here. If you've got things flowing in one path, and you have this substitute into if you have things flowing in a different path. And finally, why don't we make this polynomial into a function? And to do that, you type f of x equals and put the rule. Now, we have two different ways of referencing that rule. We can reference it from its equation label, or we've given it the name Q. But let's use the equation label. That works here. But don't hit the Enter key. Go here to the context panel where it says Assign Function. And you see that you have created a function whose name is f and whose rule is this polynomial here. You'd like label reference. Okay? If we would f of t, we would get 2t squared plus 5t minus 7. So we did create a function whose name is f. Well, once you have a function, use a function call f of, and what would we like it to be? Well, this floating point number has equation label 4. Control equal. You see the computation, and again, if you want to change label to label reference, you see a complete mathematical statement, f equals. I've shown how to build a function, and perhaps at this point you might ask yourself, what about building a piecewise function? So I've cleared off the screen. I'm going to put in some document blocks here, and I'm going to enter a simple piecewise function. I'll do that by going to the expression palette and selecting this piecewise template. And then I'll start filling in the fields. How about 2x plus 1? And tab over here. Well, I'm hitting the Z key inadvertently when I'm trying to tab. Okay, so x less than 2, tab 10 minus 3x, tab x less greater than or equal to 2. Yeah, I know what happened with that letter Z. My finger is dragging. That's my left hand. I've had carpal tunnel surgery on my hand, and it's not completely healed yet. Okay, hit the enter key. What does Maple know about this piecewise function? It looks good on the screen, but can Maple do things with it? What about plotting? Can it draw a 2D plot? Well, I'm going to go down here and use the plot builder to draw this 2D plot. And I'm going to see that Maple has used a connect the dots algorithm to join up these two linear segments. But the joint is at x equals 2, and the default domain is minus 10 to 10. Let's modify that default domain. How about 0 to 4? That might make more sense to go 0 to 4. And the next thing you notice is that this connect the dots is wrong. There should be a gap there. So in 2D options, there is this discount option, which tells Maple, search for discontinuities and pay attention when you draw the graph. And so now you get the appropriate gap. And the little point there at the end of this right-hand segment, that's because that's where you have x equals 2. Now, how much more does Maple know about this piecewise function? Can it be used in solving the equation? Suppose you wanted to know where that function equaled 3. Well, here's something that you could do. Type a 3, copy it, and paste it onto this plot. And you can see graphically that there should be two solutions. One appears to be about 1, and the other one is 2 point something. Okay? So let's see if we can make an equation out of this. Control L1 stands for piecewise function equals 3. That should be the equation that you see on the screen there now. And over here as input, you can always change label to label reference. Okay, can Maple solve this equation? Well, there is a solve option in the context panel. Pick the simplest of those solve options, and you get the two solutions, x equals 1 and x equals 7/3, which is slightly more than 2. Now ask yourself this. How did I know to go here to the expression palette and make use of this template? And it's time now to go back to the Maple portal. Well, here's a way of getting to the Maple portal. That question mark gets you into the help system. And you see right here it says Maple portal, Maple portal. Now, what is the Maple portal? Well, it has morphed a bit since I first was asked to create it because of the blank screen syndrome. You know, you're looking at a blank screen and you're saying to yourself, how do I do this and what do I do now? And my boss at the time was supposedly working on that. And I would ask him in my weekly meetings with him, what kind of progress you're making? Because I wanted to see how fancy he was going to get. And after about the third time I asked him, he said, well, you do it. So I sat down and I said, what am I trying to accomplish? I'm looking at the screen and I'm saying to myself, how do I do this? How do I do that? So I created what was at that point called the student portal, which I know most about. I posed about 150, 160 questions. How do I? Then I came up with answers. So the very first one is construct an algebraic object. The very first algebraic object is a piecewise function. So the answers are on the right here, and they could either be a fully worked out example or a task template. So what is a task template? Let me show you what the task templates are. Tools, tasks, browse. And here you have a table of contents of the task template. Now here in the algebra section, you have defining expressions, functions, procedures, and then you see define a piecewise expression or a piecewise function. And here you see how one might define a piecewise function. And you see the piecewise command. You see this task template. But look at this example. The example says, go to the expression palette. That's your stack of palettes. Go to the expression palette and find this template. Start filling in the template. It says use the tab key to move from field to field. It even tells you how to have a third rule added to this piecewise function. Control Shift R for row gives you another row. Fill it in, and you have a piecewise function. So the portal, Maple Portal, and the flavor that I know most about is the student portal because I wrote that. 160 some odd how do I's with an answer of some sort. Either it'll be a task template or a worked out example. Okay, so I'm going to remove all these. And we're going to move on to another topic. Let's clear the screen. So we'll do a Control A and a delete and put in some document blocks. And let's tackle something like implicit differentiation. Here's an equation that defines an implicit function. X squared, how about 3x squared minus 5x, and I got to put a space before I put the y, plus 7y squared equals 11. So then we have an equation that defines either x of y or y of x implicitly. I'll think of y of x. All right. So before we even worry about getting an implicit derivative, let's ask, what does this equation define? So we ought to draw a graph. So on the plots, 2D implicit plot in the order xy, and we see this thing defines an ellipse. But we can go further than that. Suppose we do Control L 1, bring back that ellipse, and let's solve explicitly for y. So these are the two branches of this implicit function, and we should draw the two branches. I'll just hit 2D plot. One branch is in red, one branch is in blue. And so you have a glimpse here of what you can add to something as routine as an implicit derivative by digging a little bit deeper and saying, well, what really does this stuff look like? So Control L1 once more. Now let's get the implicit derivative. Let's have Maple do that work for us. Differentiate implicitly. Okay? I would like y to be my dependent variable, x would be my independent variable, and Maple computes the implicit derivative. Very nice. Can we do that from first principles? So Control L1. Let's replace y with y of x. So evaluate at a point, and let's change y to y of x. Now you can see where the invisible x's are. All that remains to do is differentiate with respect to x. And finally, isolate y prime. So to do that, let's go over here to solve, isolate expression for the derivative, and you have the implicit derivative, and you've gone through it stepwise. There's a task template for this. I've showed you where some task templates are. Tools, tasks, browse, calculus, differential, derivatives, implicit differentiation. This is the task template that I would make use of. It can be inserted by clicking one of these two buttons. Default content means you get extra verbiage. Minimal content means you get enough to make it work. So let's do a clear. Let's put this equation in. I guess I'll do a copy here and a paste. This is dependent y, independent x. There's the implicit derivative. The 4 steps that we went through to obtain this are implemented in these buttons. First, you make every y a y of x, and then you differentiate. Now, the student who's having trouble with this differentiation can launch this stepwise tutor. All right, let me show you what the tutors are. Under Tools, there's this collection called Tutors. In single variable calculus, there are 3 tutors of a similar ilk: differentiation methods, integration methods, limit methods. Those 3 are step-by-step tools, pop-up tools, where the student can, or the user can, implement the various rules of either differentiation, integration, or finding limits stepwise by pressing an appropriate button. So this tutor, or this task template, calls that tutor, and it has the expression in it, and a stepwise process of differentiation can take place. If you do something foolish, like say quotient rule, it says no, don't do that. It tries to push you towards recognizing that there's a sum here. If you don't see it, press next step, and it will tell you, oh yeah, sum rule, and this is what happens when you apply the sum rule. And then rule by rule, you apply the appropriate rule. For example, derivative of a constant, so you press that, you hit 0. Constant multiple, the 3 comes out. the derivative of x squared yields to the power rule. This is a product, but it has a constant multiple. You could go up here to understood rules and say, oh, I understand the constant multiple rule. Don't bother me with that. Well, let's see what happens if we do that. So at this step, I think you're still going to have to take it out because it hasn't come out yet. This step, you're going to have to take it out. Okay, this is a product. Press the product rule. Derivative of the x yields to the identity rule. Then the y prime is written here. This is a chain rule. Click the chain rule. You get derivative of the outer function evaluated at the inner function times the derivative of the inner function. When you press close, you get this. Isolate the derivative, and if you're working with pencil and paper, you turn y of x back into y. So this gave me an opportunity to point out the tutors, one of which you've seen here. I think we have time to look at a differential equation. So Control A to select everything, hit the delete key, clear the screen, bunch of document blocks. Let's put in a differential equation. I'm going to do a constant coefficient second order to model an oscillator, damped oscillator. Now, y double prime, that's differentiation with respect to x. And since this is a dynamics problem, it really should be differentiation with respect to t. So if I put the t explicitly, I can get away with using prime. I can, in fact, differentiate with an overdot, and that would be with respect to t. I will jump up on top of the y and put two dots, two periods, and that's differentiation with respect to t. To do that, you would need to press three keys: Control, Shift, and the quote key. That will jump you up on top of any character. Then put two periods, and you get differentiation with respect to t. Now, delete this. If you go to the View menu, Typesetting Rules. Okay, this brings up what's called the Typesetting Rule Assistant. In this lower left-hand corner, you see prime is associated with differentiation variable x. Dot is with respect to t. Now you could use this dialog to switch that. So you could make prime be with respect to t. Oh, well, let's not do that. It's much easier to just put the t in here explicitly, and we'll go from there. So some damping for y prime of t plus 13y of t. Now you notice you got to put the t in every appearance of y. Let's drive this, how about cos of 2t as a driving term. Now if you look here in I guess before we do any looking, any place we should look to see that we put a plus sign where it needs to go. Okay, so then you look in the context panel and you see two items that refer to this differential equation. Solve the DE, you would get the general solution to arbitrary constants. Solve interactively, that will bring up a tool that used to be called an assistant, but now down with the tutors differential equations, it's this. So it used to be called the ODE Analyzer Assistant. It's now considered a tutor, and it can be accessed through the context panel when you say do it interactively. And the value of going through the context panel is that you don't have to enter the differential equation into this assistant. You have a choice here of adding either initial or simple boundary conditions. Y at 0, let's give it a value negative. Well, let's give it a value 2. You add that, and then there's a drop down, so you say y prime at 0, how about negative 1? Add that, click done. You have an initial value problem that can be solved numerically. It certainly can be solved symbolically. So you solve it symbolically. You say, okay, maybe we'll give you the solution. You want to see that in a bigger window. There's the solution in a bigger window. You want to draw a graph. You click plot. What you've got is a graph of the solution. If you go to plot options, you can graph the derivative also by saying, give me a copy of y. Change y to y prime. Now the graph will show a plot of both y and y prime. If you check this box, you'll see the commands. There's a desolve command that solved the equation and a plot command that drew the graphs. You can return the solution, you can return the graph, you can return the Maple commands, or you can return nothing. So this is a very useful tool in a differential equations course. You can discuss the concept of the oscillator and its behavior without having to confront the syntax that it takes to solve the equation and draw the graphs. Then you can get into the mechanism of the details of how you do this stuff in Maple, but or even mathematically, but at least you have a tool like this for getting at the content in a conceptual way without having to struggle with syntax. And I think with that, we may be at a point where we should say, are there any questions? So I'm going to close this, and I'm going to close this, and I'm going to say here, my email address, rlopez@maplesoft, if I could, .com. If you have a question that you want to send me offline, there's my email address. Otherwise, we have a few minutes here. Let's see if there are any questions.